Hello, everyone. Welcome to the PDF Association's webinar on mathematical content in PDF. I'm Duff Johnson, the CEO of the PDF Association, and here to open the door, so to speak, invite you in to join our four experts as they discuss this new guidance from the PDF Association. Neil, you want to change the slide? So this is a discussion that's going to be all about accessible mathematical content in PDF. We're going to have a presentation offered by these four presenters, and then we'll take, of course, your questions. In this presentation, I want to introduce David Carlisle. He's the editor of MathML and also does a great deal of work in the LaTeX project. Boris Dubrov is the CEO of Dual Lab and the chair of the PDF Association's LaTeX project LWG, or Liaison Working Group. Frank Mittelbach is the technical lead for the LaTeX project. And Neil Seufer is the developer of MathCat, which is a key piece of software in enabling accessible math. So without further ado, I'm going to turn it over to David to begin the presentation. I do encourage you, if you have questions, to add your questions to the question pod so that we can begin to line them up for after the presentation. Okay, all over to you, David.
Thank you. So we're discussing mathematics in PDF. So it's not just math documents, general STEM documents with large mathematical content. And these have always been difficult for various reasons. Maths has a lot of special symbols, and it has a sort of two-dimensional layout. So fractions, superscripts, matrices, they all not laid out on a line like normal text. And that causes issues in several places. So screen readers, even if the symbols are mapped to Unicode, typically can't read symbols as if it's just read as text. Reflow adaptation. So modern PDF readers can reflow PDFs to a certain extent, but it typically wouldn't work for the maths expressions. And people can cut and paste things out of PDF files. You can these days you can cut out headers and things, a document. You can cut and paste it into a Word or whatever, and a lot of the structure is maintained. If anybody's ever cut and pasted maths out of a PDF file, they've probably had a very unpleasant experience. It's usually totally scrambled historically, because the PDF just really lays out the characters on the page. HTML conversion has always been a thing for PDF since probably the start, but typically, again, most text will convert to reasonable HTML, but the maths often was just each individual expression was made into an image and put back in the HTML as an image, which is bad for accessibility. It's bad for visual use as well. Usually the fonts are wrong and the alignment's wrong. So getting accessible documents that conform to standards is hard. Getting accessible documents that are actually accessible and work is even harder. And it's becoming more pressing now. I mean, obviously it's always be a good thing to fix that, but laws in Europe and the United States and elsewhere are making this mandatory now for a lot of publishers and educational establishments. So next slide, please, Neil. Yeah, so as I say, the traditional approach has often had images of equations. And basically in PDF accessibility, mathematics was treated as like an image. So even if it was actually as text characters within the PDF, for accessibility, you just required an alt text. So a natural language description of each formula in theory will be added. So this isn't it doesn't match the structure of mathematics at all. So this PDF, this slide you're looking at are the tagged PDF you'll see later. So that's an image there with an alt text. And if I was reading that, I'd say A plus 1 over B plus 1. And it's got an alt text, which I'm also showing there, of A plus 1 over B plus 1. So that alt text doesn't really distinguish. If it had been A plus 1 over B plus 1 with a B plus 1 in the denominator, it would have sounded the same. And also, if you read that in a screen reader, it says a plus 1 because it thinks it's an English sentence starting with a short A. So it's not really understandable. And adding an alt text is kind of hard. Next slide. Yeah, so alt text can be very long. I mean, that was a very small expression, but a math display could be half a page, and having an entire description of it as text is quite hard to understand, even if it's a good description on a screen reader. You don't have any structure. So in a table, which is a similar thing in a PDF, screen readers have a lot of support that you get halfway through the table and you forget where you are. You can ask it, what column am I in? What row am I in? Reread the last cell. But an alt text is just text. Um, Different users use screen readers for different reasons. So you might be completely blind and need it reading. You might be dyslexic and just want some help. And the amount of verbosity you need, do you want it to say begin fraction, end fraction, or just A over B? Um, if you have an alt text, the end user can't choose. And again, Braille, mathematical Braille is like mathematical notation. It's very concise and fits on a one-line Braille display. If you take the Braille of the English description in the alt text, that can be many, many lines of the Braille display, and it's not really usable. Yeah, and if you look at a maths research paper, it could often have anything up to say, 50 or so math expressions on a page. Who's going to add these alt texts? Well, the author obviously knows what the mathematics means, but isn't very aware usually of the requirements for alt text for accessibility use. And if it's being added by a mediator later, they probably don't understand the mathematics. So the alt text, it might pass some accessibility tick box, but it may well be the wrong mathematics, which isn't so good. So in the later slides, we'll see how to avoid these sort of problems, which have plagued PDF for years. So next slide. Yeah, so like any area, there's lots of acronyms and names and buzzwords. So we thought we'd collect a few on this slide. Starting with tagged PDF, that's actually a defined term in the PDF standards, both 1 and 2. But basically, it means rather than just laying out characters on a page, the internals of the PDF have, you can think of it like HTML. It has tagging of the structures, so headings, tables, mathematics on a good day, and that's that. It doesn't affect the visual printing of the PDF. It's the internal PDF structure has some structure. So WT PDF, that's well tagged PDF. That's a document from the PDF Association and just a general concept of telling you how to use these tags properly. You don't want to tag your images as tables and tables as headings, and so there's guidelines on that. It's very similar to the web content accessibility guidelines, if you may know from HTML. Matching that from ISO, there's PDF UA, which is PDF Universal Accessibility. What PDF UA 1 is for PDF 1.7 and more PDF 1. Anything, more or less. And we're not going to talk about that a lot because it's not too good at mathematics. It just uses alt text as we just seen. And PDF UA2 is a newer one. It's very close to the WT PDF document that were developed in parallel. And that tells you how to do accessible PDF2 documents, which includes MathML support. Associated files are a thing in PDF, so you can attach, as well as the main typesetting content stream, PDF allows internal files. So depending on how you add them, they might show up in some PDF readers and the table of contents. But in this context, it allows us to attach MathML or CSS, extra structure to help add structure for the math. MathML is a markup language mathematics, it says here, and it's originally developed really for HTML, but it's also can be used in PDF too. But there's a lot more about that. In fact, the next slide, I believe Neil will take over on some MathML details. Over to you, Neil.
Yep, thanks, David. Yes, so I'm going to talk about MathML. It's part of HTML, but it gives structure to it. So just like in a HTML, you have a table, you tell it it has a row, and here's the contents of a row with the data, and those are all different tags. So MathML has a bunch of tags. They typically start with M for math, and that keeps it out of the way from the other tags. I have an example here. You see all the funny angle brackets. That's just like the other HTML tags. This example is the cube root of X. And so it begins with an M root. And there's two parts to it. You have the radicand, which is the X, and that's a math identifier, an MI. And you have the index, which is 3 to make it a cube root, and that's an MN. And that's the three parts, or that's the parts to make it MathML. And MathML enables user-enabled speech. So unlike alt text, where you generate one speech and it's good for everybody, with MathML, the assistive technology, the screen reader or the learning disability tool can choose the appropriate speech. It allows it to, the structure is there, so you can highlight individual parts of it. You can navigate within it, so you can zoom in and move out and move around. And as David said, you don't get the words turned into Braille. Just like mathematical notation, each Braille code has its own special way of dealing with math, so it's more concise. In the US, we have two different Braille codes. One is UEB, another is Nemeth, and the author can't know which is the right one because they don't know which math Braille code a person might know. And then, as David said, you often take the PDF and turn it into HTML. And if you have it tagged as MathML, well, HTML uses MathML, so that export just works. Assisted technology, then, it needs to understand that structure in order to be able to speak it. It needs the proper reading order, which is, again, given by the math. It can understand it from the MathML. You have a ton of operators, like in this example, you have an integral sign, you have the square root sign, you have an equal sign. And so all of those need to be pronounced properly. And if you know the MathML, then you predefine how these things work. You have structure, subscripts, superscripts, fractions. And then MathML 4 introduces a new idea called intent. And this allows authors to, without giving the exact speech, it allows them to say what's meant when something's ambiguous. And I'll get to that in a minute. Without the semantics, well, the speech becomes ambiguous. David already gave an example where he wrote down some alt text, but it didn't have a begin and end tag. So that's a problem. The screen reader would know to add that. But of course, if you're not blind and can see the screen, you don't want that. So again, the assistive technology, whether it's a screen reader or a learning disability tool, it knows what the audience is. And the users often have some control about that. The navigation fails because, well, it's just a jumble of text that was drawn on the screen if you didn't have the MathML, but with it, there's structure and order and so on. And again, the Braille, you can't read it if you don't understand what the math is. And here you have it. So copy paste, again, instead of having a jumble of stuff, you have the structure. When you copy it, it's going to copy the MathML or some other format that can be derived from it. And then you can paste it wherever. Similarly, if it's just a jumble of text, you can't really search it because you don't know the order of the text. But with the MathML, it can be searched. The latest version of PDF, PDF2, as David said, it introduced standardized support for MathML. So that meant that it knows about the MathML namespace. It has a feature called associated files. Associated files aren't actually a file. It's a chunk of text, a stream inside the PDF. And that stream can then point to the formula tag in that tag tree that David mentioned. And that is how you can associate, that's how you give structure to a formula. It gives that semantics representation rather than being just a random stream of characters. The older PDF 1.7, you were stuck with alt text officially, and we've already talked about why that's a bad idea. The new guidance says explicitly, if you have a lot of math, you really need to be using MathML. So what I'm going to do now is navigate this. I'm going to turn the screen reader on. I'm using NVDA, which is a free screen reader.
Speech mode talk.
So hopefully I'm at the right point now.
The fraction with numerator x plus 1 and denominator y plus 2.
So that's reading the PDF. And in fact, all the equations in this document are readable by a screen reader. I've mentioned that you can navigate it, so I'm going to go ahead and do that. Hit the Enter key.
Math. The fraction with numerator x plus 1, and denominator y.
Well, that's pretty simple, but in a larger context, maybe you need to explore that fraction a little bit. So I can hit the down arrow and move in to the fraction.
In numerator, x plus 1.
And I could dive in further and explore that, or I could hit the right arrow and after the numerator.
In denominator, y.
And I could go backwards to the numerator, or again, I can hit the right arrow.
Out of denominator, plus.
And continue along with the right arrow.
2.
And if I hit right arrow again.
End of math.
And I could go back.
Plus. The fraction with numerator, x plus 1.
So that's what we can do with it. That was reading in a style called ClearSpeak, which is the second line of this table here. There's other ways it can be read. So it could have been read as fraction x plus 1 over y and fraction plus 2. It's a little bit shorter, a little less conversational. And if it had been a learning disability tool, you probably don't want to hear the fraction and just you want to hear x plus 1 over y plus 2 because you can see where the fraction begins and ends. So you don't need those extra words. And in fact, they get in the way of somebody with a learning disability. If I were a Spanish speaker, which I'm not, the third line there is the Spanish representation. MathCat knows about 10 different languages currently, and more are being added. I won't say every day, but every year we actually are going to add about 4 more languages at the end of June. And just as I'm not going to speak the math, I'm not going to speak that fourth line, which is Braille. That happens to be UEB, which is used in a number of English-speaking countries. It's Unified English Braille. And as I said, it can generate several different Braille codes.
The fraction with numerator, semantic math approach, represent the actual
turn the screen reader
speech
off.
Mode off.
I mentioned earlier that authors can help disambiguate the math notation. So here's an example where we have bar over x plus bar over y is equal to bar over the quantity x plus y. Well, in a math class, you would never say that. If you were in a statistics class, that bar over the x would be the mean of x. And if you were in an Algebra 2 class or a calculus class, it's often going to be something like the complex conjugate of x. And they look exactly the same. And the screen readers couldn't really speak that particularly well. But in MathML 4, we've introduced a new concept called author intent. And the author can say, oh, this is the mean, or this is the complex conjugate. They don't give the exact words because they don't necessarily need to say begin and end for each of those. And let the screen reader then can decide that. But it will now know it needs to say mean or complex conjugate. So that's the MathML. Let me turn it over to Boris.
Thank you, Neil. Creation of accessible math requires newer standards. The best practice guide recommends the use of well-tucked PDF or PDF UE2 that is based on PDF 2.0 itself. You have references to these standards at the end of the slides. The complete, all technical details are provided free of charge thanks to the sponsorship of PDF Association. Well, the main reasons why we need the newer standards are because these newer standards improve the definitions of semantics, define better and more predictable processing instructions, processing behavior for the software. They introduce a notion of namespace, and MathML becomes its own namespace. And in general, it defines how MathML structures interfere with the rest of the document. And again, thanks to the use of the associated files, the creation of accessible math is highly simplified, and it's supposed to be done fully by some processors. So thanks to these standards, accessible math really becomes the first-class citizen in the PDF world, and in general in the world of STEM publications. Next slide, please. In particular, this best practice guide is published also as an example implementation. So if one wants to see how exactly the accessible mask should look like, you can just look at this PDF. It itself conforms to PDF 2.0, to PDF UA2, to PDF A4F conformance. So if you know this, what is PDFA? So PDFA stands for long-term archival, as well as well-tagged PDF. It is vendor neutral. It's published under a permissive Creative Commons license. It also uses all these new features like associated files. It does encode all formulae as MathML structures. Moreover, it has some CSS so that if one wants to turn this PDF into HTML using yet another PDFization technology called derived HTML, the final appearance looks very nice. Next slide. And I pass to Frank.
Hi. Okay, so we are now coming to the implications for different groups. And upfront, perhaps the biggest group that benefits are the people who are actually in need of AT software support and want to consume STEM documents. With 2.0, UA2 and MathML, they really get truly accessible content for the first time, and not just sort of a fig leaf laying over the PDF to satisfy some regulations by testing against UA1, but being not really accessible for people who actually want to access it, not by looking at it. And we don't have a slide for it, but I think the previous part of the presentation has already clearly made that clear what is about this. So the next implications are for the publishers. Basically, the statement is they should transition towards this actually not so new standards as soon as possible. This will, first of all, greatly enhance the accessibility of the documents, but also it will help them to reduce remediation efforts to make things accessible, and therefore also, of course, reduce the costs. That will have a huge impact to various parts in STEM, in the STEM arena: education, scientific, government, technical documentation, and so forth. Next slide, please. So implications for software developers, we basically have three groups here, I would say. First of all, there are the PDF producers. They should need to move to these standards and support them correctly, and importantly, also take care of actually producing the math structures using MathML directly in their tools, because that's the best place to have it, and not to put it after the generation of the PDF and do some remediation and fix things then, because that means the documents will never have a truly good accessibility there. The second group is the producers of PDF viewers. There we have, of course, the need to understand PDF UA2 structures and pass them on to the AT. That's something which in case of, for example, the browsers, until recently has not happened at all. Browsers just choose to ignore structures in the PDF and just applied heuristics. This has now changed. Firefox is supporting that fully, and we know about the fact that Chrome people are working on it, so there's a good chance that this is drastically changing in that space, and we will see better and better support over there. And finally, the last part, which is also very important, is actually validation of accessibility. There we have the situation that unfortunately a lot of validators are still just checking against UA1. So you get a perfectly valid UA2 document, and some validators are going to tell you this is not valid because you don't have alt text on each and every formula. Again, we see movement here, and it's very much needed because the goal is to have good accessibility, and so validators should improve the situation. Next slide, please. This is the current situation of the software. Things are moving, as I said, so this is hopefully soon be getting better and better. From the authoring systems, we have at the moment LaTeX as a major STEM producer who can produce accessible UA2, as well as Microsoft's Word and PowerPoint. So there's a good part of the site already covered. On the PDF viewer side, Foxit does it, Acrobat can handle it, and as I said, Firefox, and hopefully the other browsers will follow. On the validator sides, we have Vera PDF, we have Show PDF tags, and OctoPDF, so you can actually validate this, but you might find that some other validators that are being used in organizations are actually telling you the wrong information if they see a UA2 file. So that's unfortunately not yet all good, but the space is moving. Next slide. So key takeaways. We are seeing, and we have the need to move and transition away from alt text towards structured approaches. With STEM documents, alt text is basically unusable, either because it doesn't scale. You cannot easily put alt text on 50 to 100 little fragments of mathematics on each and every page. And as it was explained earlier, it is basically difficult to get things in any way good, and it is not customizable, which is an important part of accessibility for the user. What we also talked about is the fact that it is important to move in this workflow to provide everything in the producer side and not having a post-processing step, because that breaks development of documents, because you have to repeat everything, or you have to do it at the very end, which we all know usually there's no time and no energy to do this. By having a workflow as outlined, you end up with accessible documents out of the box, basically. And as we said, it needs PDF2, PDF UA2, as well with MathML if it comes to STEM documents. Otherwise, the quality is very much reduced. And it is not just increasingly becoming the law, so it's very important. It's also a very good goal in itself. First of all, for the people who need it most urgently, but basically for everybody, simply because it is not just accessibility in the sense of you are being blind or visually challenged. It is also helping with all kind of other accessibilities, reuse, the possibility of copy and paste, and so on and so forth. So it is helping everybody. Next slide, and then I guess over to, yes, Duff.
Thanks, Frank. So I'm here to introduce, well, to first mention that on screen right now, you see a number of the resources that we've been referring to over the course of this webinar. And this document, to reassure those who have wondered, this document will be posted, and these links obviously will be actionable, so that you can locate these resources or find them on pdfassociation.org. And it's now time for me to invite back our all of our panelists to turn on their cameras so that we can begin to go through the enormous pile of questions that have been stacking up. I'm going to ask our panelists to stick around. I'm going to try and get through as many questions as I can handle, and we'll see whether or not if our panelists didn't give me a strict time when they have to leave, so we might do this for a little while, but you can also let me know if we're not. So let's kick off. So I've captured a lot of these questions, and there probably is scope for probably maybe a few more, but let's just get into it. So Neil, one questioner wants to ask: Are you using with your reader? Were you using MathCat?
Yes, that was MathCat inside of NVDA. A bit of good news is it used to be what NVDA called an add-on, and a few months ago now, maybe 2 months ago, NVDA built MathCat in, so there's no longer an extra step for it to be used. If you were using JAWS, it also uses MathCat. It's they don't expose as many options as NVDA does, but that's another option. And if you're a Linux user, I don't think there are too many Linux users in the audience, the Orca screen reader also uses MathCat. And there's other accessibility tools such as Kurzweil 3000, which does the synchronized highlighting for learning disabilities, and tools that are used in Europe, such as Dolphin's Easy Reader, that take advantage of MathCat. So there's a lot of use of MathCat.
Great. Thanks, Neil. Okay, I think this next question is for Frank. Frank, this questioner asks, I understand there's a replacement class for Beamer in development. I know we've talked about Beamer before. How difficult will it be to convert a lecture of 100 frames?
On the whole, I think the answer is very simple. We try to make the Beamer replacement not a one-to-one, but largely a one-to-one. So what you see right now is done with the new class, which is still under development. So there are things, there will be many further improvements, but on the whole, we try to keep all the reasonable interfaces of Beamer. So it might have some adjustments that are necessary, but they should be fairly okay. That's at least our goal. David, you want to say anything on top of that?
Yeah, Joseph, who's on the in the audience, has just commented. He's the lead developer of the class. He just commented that his lecture notes. He's a chemistry lecturer with over 100 pages. Basically, most of the Beamer functionality will work almost without any change. If you've got lots and lots of fine Beamer customizations on, fancy themes and styles and stuff, that doesn't all work at the current stage. But getting the slides to work and the overlays and everything is essentially no effort at all.
Okay,
yeah,
great. So next question. Long time ago when I came across MathML, I remember there are two ways of MathML, a presentation style and another style. Is this still the case?
Yes. There's content MathML, which is more marking up the meaning of maths, not the layout. But in this context and on the web, just concentrate on presentation MathML. In fact, MathML Core, which is a new standard in development, which is basically the subset of presentation MathML that web browsers implement, because that the advantage for both HTML and here is that ties directly to the layout that you see on the page, whereas content MathML will tell you that it's an integral, but you don't have any tie back to the actual notation. So yeah, just for this context, just concentrate on presentation MathML.
Okay. So this question, so let's see here. So how many new test conditions will be introduced to the Matterhorn protocol to support MathML and PDF accessibility? That's probably a question for me, I guess. And the answer is that the Matterhorn protocol 2.0 is in development right now, and any support for MathML in Matterhorn would be added to Matterhorn 2.0 and not to the existing Matterhorn, which only addresses PDF 1.7 and PDF UA1. So the answer is, although it would be our intention to ensure that MathML is represented in the updated Matterhorn protocol, I have no idea how many test conditions that implies at this point.
Well, I can probably
Boris
follow up a
knows.
little bit.
Yeah.
Yes. Well, so Matterhorn covers essentially all requirements of PDF UA standards. So Matterhorn 2.0 will cover the requirements of PDF UA2. And formally, if you look at the text, there are not that many requirements, literally. So I would expect less than a dozen of test cases, maybe even less. But of course, if you want to have a full validation of math inside PDF, you would need to check that MathML inside PDF is also valid. And that will most likely be, well, outside of Matterhorn itself. But well, that is still work in progress, so we don't know.
We don't know, right? Okay. Okay, so hi everyone. I'm a researcher in the field of accessibility for the publishing industry. I understand the use of MathML, but for notated formulas that are so common in educational textbooks, when a formula when there's textual information pertaining to the formula, such as this is the denominator, what would be the right solution? Asks this person. So I guess guidance on components of how to identify components of math.
I think that's a tough question, and that's why I think neither David nor I wanted to jump in right away. It's hard because that sort of breaks the structural link of how HTML and MathML, and PDF work, because you're kind of pointing from one thing into another, into the middle of something else. You're kind of jumping into the structure. I suspect you could have a link, so you can put links on parts of the MathML and you could point into that. But yeah, I don't have a great answer to that. David, do you have one?
No, I mean, MathML has an MTeX, so you could actually make the annotations part of the MathML, but you probably don't. You probably in the PDF, the structure doesn't have to exactly match the visual representation. So if you've got a math expression, and then you have some yellow boxes with text and arrows and stuff that's around it, they can be tagged separately. How you arrange the reading order, there's no right answer. It's hard. I mean, the other things are hard as well. If you have commutative diagrams and things, it's not always there's still partly because there's not the vast experience of doing this for real documents in real practice. So yeah, it's there are various things possible, but exactly what you need to do, you'd have to experiment a bit.
I think one thing that would be good is actually, and I think it is under this link on the resources, you get to the LaTeX tagging project repository, and there we have discussions and issues that's directly related just to LaTeX. But to pose that question on those discussion on the discussion page of the GitHub repo would help us to record these kind of technical requirements, which, as David and Neil said, in some sense may not have been considered so far. So it could be brought back to the technical UA working group to try to find answers how to best manage those kind of things, and then see that we get those automatically supported, or getting interfaces to it, or at least getting guidance to it.
Okay, that's good. Who wants to take this one? Can you define namespace generally, at least with respect to what we're doing here?
Yeah, it's a space of names.
Okay.
No, so
David.
yeah, so in both HTML and PDF, it literally is that. So as Neil said, if you think about HTML, there are tags that you may know, like P for paragraph and table for tables, and they're all, you can call them HTML, but in the system they're the HTML namespace, which is w3.org 1999 math. XHTML. I got that wrong. And the math ones, as Neil said, you can usually, if you know them, you know their math, but they're all technically associated with the URL for MathML, and they're the namespace, that URL. Any tag associated with that URL is in the MathML namespace. So if it's one we have defined, like mi or mroot, that's a valid tag. And if you put a p in the MathML namespace, that's invalid. It's not. P is supposed to be in the XHTML namespace. And similarly in PDF2, for the tagging, there are certain standard PDF structures for tagging, same sort of things, headings and paragraphs, and they're in the PDF2 namespace, which is a URL which Duff could obviously tell me because he'll remember, but it doesn't really matter. It's just a boilerplate string which identifies the standard PDF tags. And then you say MathML URL for math.
So another way of saying it is that namespace is sort of a prefix to the tag, and it keeps every tag unique in its own namespace. And in HTML, MathML and SVG occupy a special space. They're the only ones in a separate namespace. So yeah, it's something you probably don't ever need to think about. It's a technical detail.
Okay. What are realistic approaches for adding MathML to existing math-heavy PDFs without completely recreating them?
Oh,
Sounds like
I can try. Okay. I can say that first of all, you need to make sure that your document has all proper structure, so it's tagged. So you may have old PDF documents that don't have even structure inside, and that's number one task. And then, well, if you have already all tags for everything, including your formula tag for mathematical formula, well, there are technologies that would recognize your formula and convert it to MathML. I don't say that's an easy task, but to me this sounds feasible, and you don't need to do it manually. Absolutely.
Yeah.
Whether the existing software is able to do this, I don't know. Well, not a free one, but maybe there are some commercial software that does something around this. But I know that these recognition technologies are very powerful. So maybe in the nearest future, there will be tools that do this for you.
And in case of LaTeX, if you have the PDF and it was produced with LaTeX and you have the LaTeX source, the goal of what we are currently doing in the LaTeX project is really to enable also for old documents the automatic generation of tagged PDF in UA2. So in other words, ideally by just adding a single declaration at the top of your existing file and reprocesses in LaTeX, you would get, in the end, the project isn't finished, so that wouldn't work for many old documents yet that are very complex. But basically, that's the goal, that you, without much modification, the LaTeX-based documents would be reprocessable and become accessible this way.
And just to give the word side of things, again, if you have the original document around, just open it up in a modern version of Word. If it was using the math type equations, Microsoft has added a way to convert them all to Word equations, and then you just save as PDF and it's magically accessible.
Okay. Does MathML in PDF support chemistry notation?
Yes.
Yes, it's there's a caveat. So if you had something like H2O, that's supported. It will be read appropriately. If you have, something where you have a yields or other types of things, it won't just say right arrow, it'll say yields or some such things that are in equilibrium. It'll say equilibrium for the arrows, but it won't support structural diagrams because you can't represent them. So those are like a benzene ring where you have various arrows connecting the carbons in a circle. But if it were a simple one where you have C dash H dash something, then yeah, that can be represented in MathML. And at least MathCat will try to speak that properly.
Okay. So next question here. Do you have to use LaTeX to author MathML in PDF? This questioner asks, I've seen that Word's equation editor supports a version of Office MathML that pulls that does transition into a formula tag in PDF, and they want to know, is this accessible?
Yes, Microsoft has done a tremendous amount of work on accessibility in their math editor over the last half year or so. And yeah, you just use their math editor in there, and when you export it as PDF, it'll out it goes. And Word itself is now pretty well, Word and PowerPoint now are accessible directly also.
There was a big update on that this month, last month. So the last link in our resources link page
Yeah.
has a Microsoft blog on the latest update of Word on that
Yeah.
topic.
So how mature is the LaTeX to accessible PDF workflow today, and where are the biggest gaps?
You or me, Frank? As Frank said, there's a medium-term aim to be able to sort of do the majority of existing documents. I mean, like Archive has got roughly 2 million LaTeX documents, and we'd quite like them all to be accessible. Archive would like them to be accessible. Currently, the workflow works very well for new documents. If you're writing with this in mind, really a LaTeX user only really has to add some declarations, and it more or less just works. If you download a random document from Archive from 10 years ago and try and add the declarations, which I do sometimes, it clashes with weird packages you've never heard of, or even weirder markup that the authors put in the document. And so you often have to clean up the LaTeX to make it compatible, because some documents just overwrite all the LaTeX definitions and so remove all the tagging support. So it depends a lot on the document, but for new documents, really, it's production ready now. You can do this. When you get for this talk here, the maths, there's no special tagging for the maths. It's just normal LaTeX you'd recognize since the 1980s, really, and it all comes out and gets read in MathCat.
Okay. If MathML does not support my native language, excuse me, is it possible to use English MathML and give the MathML tags a language attribute so that the screen reader knows to switch to the languages used?
Yes, and that sort of actually will happen, at least if you're using MathCat automatically, because it defaults to English when it doesn't know the language. So we're adding lots of languages in MathCat. There's a lot in the world, and I encourage you, if you're interested in helping develop a language, we don't have a link to that, but to look up Mathcat on Daisy and GitHub and create an issue saying, I'd like to help get this language implemented.
Okay. Two questions here that are related. First question is, does the PDF Association have documentation to aid publishers in developing PDF 2.0 workflows? Well, the documentation, the publication that we're just now promoting, so to speak, with this webinar, which is the guidance on including MathML, is one such of our guidance. There are a number of different, in fact, there's another article just now on the news page of the PDF Association website that includes links to a number of different articles by Peter Wyatt that are all about PDF 2.0 and supporting PDF 2.0. But we're not the association is more about developing documentation and support content for developers rather specifically than end users because that tends to be very oriented towards particular tools. Regarding the document that we're discussing here, Math in PDF, one questioner asks, the documentation seems written primarily for LaTeX-based publishers. Is there additional information for HTML, XML-based publishers?
Oh, I can try answering this. So the document indeed includes a few examples in LaTeX, but in general, it's neutral to the authoring software, and all definitions and requirements are not directly based on LaTeX terminology. So I would say that it's fully applicable to the authoring software that converts HTML to PDF.
Okay. There are two questions here, or a couple of questions actually, about when will Adobe support PDF UA2? That's not for us, and I can simply say that's not for us to say. Any particular vendor's moves to support any one thing is something that there's nothing really to do with the PDF Association. And I don't have any specific knowledge or information about that I could offer. Next question, how does PDF tagging associate equations to equation numbers in a legible way? This questioner asks, I remember this being an issue in MathML core due to the removal of M-labeled TR. Yeah, thanks, David, but I'm not up to date.
The intent mechanism that Neil showed distinguishing complex conjugate from mean can also be used to distinguish, round bracket 1 as being a label rather than part of the formula. When you get hold of this PDF file for the talk, there's Maxwell's equations, which are on the first page. It's a display of 4 equations, and you can get Mathcat to read them, and it will say, on the first or second slide, wherever it is,
very first,
it will say 4 equations. Equation 1 with label 1, equation 2 with label 2.
You can maybe just hear it. It's probably pretty.
Oh yeah, Neil's got Mathcat running. You could,
if you can do it. It's probably quite illuminating.
Yep. Let me move to that. Oops.
Nearly.
Oops, I'm sorry, I have to deal with the screen reader issues. Let me get it to, there we go. So I'll turn the screen reader on.
Speech mode talk. 4 lines. Line 1 with label 1, divergence of bold E, is equal to the fraction with numerator rho, and denominator epsilon sub 0. Line 2 with label 2, divergence of bold B, is equal to 0. Line 3 with label 3, curl of bold E, is equal to negative the fraction with numerator, partial derivative bold B, and denominator partial derivative T,
Okay, so I think that's probably
Yeah,
enough to
that's
get an
enough.
example.
Absolutely. But the important part is this is
Speech mode
automatically
off.
generated. I mean, the LaTeX source, this is a LaTeX presentation class, just contains a line,
Yeah,
beginner
it's just
line,
it's just
end
it's
line
just
or
standard
something.
AMS math line.
Yeah,
And
just normal mathematics, and this is what comes out.
even the divergence and curl, I didn't add intent for that MathCat. I just used Nabla, which is the upside down triangle thing, and then MathCat spotted the following dot or cross and said div or curl, whichever it is. So yeah, but if you looked at the text source, literally it would have worked in 1993. There's no special markup at all.
Okay, great. So another question here is about this person wonders, how is there a way we can pressure PDF readers to be fully compliant? And they note that they've had poor experience with different PDF readers trying to do math and so on. And I would simply say to them that the way to pressure the vendor is to contact the vendor and send them and tell them what you want. And you can be very specific now because you've learned a lot of information about what's possible in for accessible math in PDF, and send them links to the guidance that the PDF Association publishes, to this webinar. The real secret here to pressuring vendors to do a better job is simply to contact them and let them know in as specific terms as possible what it is you want. And this is, I can promise you, because I talk to software vendors all the time, hearing from the user is a really huge driver for them. And so
And I
that,
think, if I
yeah,
may add to that,
yeah,
I think if you are in an organization like a university or whatever, if you can get through your accessibility people to help addressing the vendor, that they know it's the whole university or the department standing behind it, it gives more,
yeah,
better,
it
faster
really adds a lot
results.
of weight. So if
Yeah.
it becomes that my institution is actually requesting this, it's not just, assistant professor of this and that. Yeah, yeah. Let's see here. Next question. We're digging through the pile of questions. I hope my panelists have stomach for a little bit more. Um, would you care to explain in briefly the workflow from LaTeX to WellTag PDF with math?
The workflow from LaTeX to WellTag to PDF with math. Well, in the resources, the link actually shows how to do it. I think it points to the guidelines for it. But basically, you add in front of \document class one additional line, which is called \document metadata, which has a key value argument where you set tagging on, and you can say something like PDF standard equals UA2, and off you go. You have currently to restrict yourself to something like 800 possible packages and a set of classes. Not all document classes are yet supported, but if you stay with that restricted set of packages and the major packages are all supported, then and there's in the guidelines is also a link that gives you the table of what is already supported, what is partially supported, what is not yet supported. Then that's all you need to do compared to doing it unaccessible.
Yeah. Okay. Let's see here. This is an interesting question. A lot of content is provided in LaTeX. Why is the creation of MathML necessary?
Oh, I can
Well,
maybe try. Yeah, there are a lot of discussions around how LaTeX itself is accessible, whether one needs to convert LaTeX formulae to some other syntax like MathML. And the clear answer was that MathML is a standard, LaTeX is not a standard. And this means that if you want to have a standardized solution that would work in, I don't know, 50 years, then you need to be based on official standards, and that's MathML is for. Actually,
if I may contradict that, LaTeX is already 40 years old, which is an older standard than most, and it's doing pretty well in that respect. But to add on it to more seriously, there are people who are in needs of accessibility who rather like reading LaTeX source. It's concise, and for that reason, we also from the LaTeX project attach the LaTeX source of the MathML as an additional associated file, so you can do that as well. It has a lot of disadvantages, and this I think is the real reason. You cannot do what Mathcat can do in terms of expanding the presentation or contracting the presentation depending on the user's need. You only have this fixed representation, which in some cases is a good way to go, which is why we also kind of support that in the generation of the PDF. But the more flexibility and the more generally available downstream is, of course, to stay on the standard, because the standard allows other tools to make use of that, which they may not want to do if they get LaTeX as a source.
So let me throw in my 2 cents too. I think the problem is LaTeX is too powerful. It's a programming language. So when you say, why don't you support LaTeX? Well, that means I have to support the entire LaTeX engine, because there's no fixed definition for what you can do. You can do anything in LaTeX, whereas MathML is more restrictive. It knows about certain notations. So assistive technology can say, that's a notation I know about. Whereas if you make up something in LaTeX, it has no idea as to how to speak that.
Sure. If you go real LaTeX, I absolutely agree. But then if you have something like MathJax, which also is not real LaTeX, but it is a restricted form and in that sense fixed, one could fix on that,
Yes.
something like that. But yeah, I mean, I think we have all the different arguments brought forward. By the end of the day, the most flexible one is really to go with MathML, because that works from all sides identically. And I mean, we see this now that we can produce with LaTeX accessible mathematics and Word followed.
Yeah.
And downstream, it can be used regardless then.
Okay. Well, I think there are a few a few more questions. This has gone. There are many more actually than I had anticipated. So I'm kind of thinking that we can't try and answer these all because they keep coming. But would my panelists like to take a couple more?
Yeah, it's fine with me.
Fine with me. Yeah.
Okay.
Absolutely.
Okay. So
If
let's
I
see
get it.
here. Is Welsh one of the Mathcat languages, or any plans to add it?
Klingon.
Yeah. No. Mathcat does support, the British are very strange in the way they pronounce some things, and it does support a little bit of the British English. Welsh is a whole nother what's
Language.
the phrase? Yeah, language. And someone would need to work on that. And I'd love to have somebody help and develop that. Obviously, I can't know many languages. So yes, I depend on the ability of other people to do the translations. It's all done now under the DAISY hat. If people know about DAISY, that's an international organization. And so they've been coordinating some of the language translations, which is great. But yeah, I'd love to have Welsh. Love to have other versions of languages that aren't as common. So yes, there's nothing that restricts that other than having somebody willing to do the translation.
Yep. Thank you. So I think we'll wrap with this one because this is a good sort of general high level question that I think will be an interesting answer. Beyond STEM, lots of ordinary documents contain the occasional equation or formula. Where's the line? When does a stretch of numbers and symbols actually need MathML? And when does tagging it as math do more harm than good?
So I'll start and I'll let other people continue. It's a what do I want to say? There's a bit of a fine line. So if you just have a variable, say alpha in there, you can probably get away with not tagging it as math. The issue gets to be if somebody's using Braille, is it going to turn into a proper Braille? So once you have any structure in there, so once you get to subscripts or superscripts or square roots or fractions, then you absolutely need to use math. So even something as common as equals MC squared, that needs to be in MathML. If you have something like A plus B or A is less than B, that should be in MathML because now you're into mathematical notation and the Braille needs to be brailled appropriately for somebody. But if you just have a number, if you just have a variable, no, I don't think you need to do that. Anybody else want to chime in?
Personally, I think you shouldn't try to guess how simple it could be to not use it. I think it is always the right thing to do because downstream, a lot of things go wrong where you wouldn't expect them. And the mathematical notation, also in Unicode, the symbols are quite different from text symbols. So if you're not tagging them as maths and then as MathML, you end up with very likely wrong results in various parts of downstream application, be it copy and paste where things are getting dropped or being incorrectly represented. So you can't really guess as a user or as a programmer or something how simple you can get by with just putting alpha as a text alpha in. That's my point, and it doesn't make sense to try to guess that because already a binary or relationship symbol will break things.
And certainly within a given document, you really wanted to, even if it's just apart from accessibility and anything else. I mean, just think about it in a normal web page or something or a PDF. You're usually using a different font for maths, and it's not always the same. So if you don't mark up, if you've got 12 that's in the displayed equation, and then you just write 12 in the following text because you can. If they end up being a different font, it just upsets people who notice font changes and makes us very unhappy. And it's no effort to put dollars around it in LaTeX or whatever. It's just better all round to just be consistent.
I would add to this that PDF UA2 does not draw a line. PDF UA2 simply says if you have a mathematical expression, you need to use MathML. So it doesn't try and, 2 plus 2 in principle in PDF UA requires MathML.
Exactly.
Yeah.
So
Okay.
Boris, you haven't said anything. Last sentence.
Well,
come on.
Probably I can just my 2 cents saying that accessibility in general requires some author intent, and it's not fully automated and fully machine based. The author may decide that this is not mathematical formula, and then he may not use MathML then. So it's fine, and that's an author decision.
Right.
But yes, as Frank mentioned here, then the author has to understand all the implications
Yeah.
of this decision.
Okay. Okay. Well, I've dragged you well past the amount of time that I said I would keep you in for questions, and I really appreciate your flexibility. So I really want to thank very much my panel of experts here for talking to you today about math, MathML, and math, actually, just math in PDF. Boris, Neil, David, Frank, you guys have been great. For those who those who have asked, yes, this recording will be this recording will be posted and the PDF. And someone also asked for David the LaTeX for this presentation. Hopefully that's okay with you.
It's okay with me if it's okay with you. It says copyright PDF Association, so if it's okay with you, that's fine.
Great.
I'll give it. Well,
So we'll have all this posted in a matter of a day or so. And of course, you'll learn about that if you registered for this webinar, which you did if you're watching it. So that's it from us for today, and much appreciate your attendance. And I ask you to carry forth the good word about math, accessible math in PDF. If your vendor doesn't adequately support it, let them know that they should. And you now have various resources and information on the web that you can point them to say, hey, it's now on you to start supporting this technology because it's possible and others have proven it. And that's really what the world needs. Again, thanks a lot from the PDF Association. Thanks to our panelists, and I wish you a great rest of your day. Take care.
Bye.
Bye all.